Hi guys, so I'm going to go through your homework on transpiration and I'm going to just try and help you approach exam questions better. As always, if I speak too fast, slow me down on YouTube. If I speak too slow, just speed me up. Right. As always, look at the objectives, okay? Just think about these are the things it's absolutely vital you need to know. So phrases like the pop up here, xerophytes, cacti, marram grass, hydrophytes, water lilies are things you need to know about, and this is the big clue. Right, I'm going to pick out some of the questions. I'm not going to do this of the easier recall ones. I'm just going to pick out some of the data analysis ones for this session. So the following graphs show results from an experiment to investigate the rate of transpiration of the same plant in different environments. So change environments. Let's have a little look then. As always, before I launch into questions, I'd like to get my head around what the graphs are showing. So volume of water lost, 120. Oh, lovely. Right. So volume of water lost is 120. Time in the bottom goes up to 120. So it's directly proportional, more or less. This one here, volume of water lost. It could be a bit of a nasty. Okay, they have changed the axes. This is kind of not a great way to display data because it's not directly proportional. This would be a much more lower if we was drawn on that graph. 80-40 and 10-40, so that would be much steeper. So they're a little bit nasty, these graphs, but you need to spot those axes, otherwise the two all look identical. Which graph A to D shows results when the plant is being grown in the least humid environment? It'd be really good if things didn't disappear every 5 seconds. Right, so least humid, so that means it's dry, and that means it's going to lose water most quickly. So I'm looking for the one that is losing water most quickly. Again, I'm something to think like you are. So volume of water lost is so it's going to be sensible then to pick some easy numbers I can do a quick bit of maths on. So this one is losing roughly 2 millimetres cubed of water per minute. This one is losing a fifth, 0.2. This one is losing 1, and this one is losing, so that's 1 millimetre cubed in 5 minutes. That's 0.2. Do I get the other one right? 2 in 10. So it's going to be C because it has lost. So I just did that mental maths. So it has just double checked before I put my answer in. It has lost 2 millimetres per minute, and all the others have lost less than that because the graph goes the other way around. So it is C. So these multiple choice questions are, you kind of think a mark a minute, but multiple choice questions aren't that. And you can see it's pretty much a page of writing to get that answer right. Okay, move down to one of the written answers now. So it shows a pedometer, and a pedometer is this. So it's a way of measuring transpiration. Now, I always say everything in this diagram is there for a reason. This is not a Google clip art. This is examiners drawn this. We've got some to draw it, and everything's important. So we've got capillary, screw clip, water reservoir, rubber tubing, leafy shoe. Now, hopefully, it's all familiar because you've done the practical and prepared well. But if you haven't, so you just think about it, water's going to move in that way. It's going to move up and out through there. Why have we got a water reservoir? Well, if I want to reset it, once my bubble is up to here, I don't want to have to kind of suck it all out, so I can put water back through, flush it back that way, and move my bubble back down to the end and reset it. That's what we have the reservoir for. And the screw clip is to make sure that's out of action when the plant is losing water. When the plant loses water, that little bubble we can see there, that's significant, that tiny bubble, is going to start moving to the right. Okay, I'm happy I know what the picture's about. Let's look at the data. Student uses this apparatus to investigate the role of stomata in transpiration. And then note the position of the air-water meniscus. What's that? So I don't know what that means, but that totally, to be honest with you. But I'm guessing they mean there, the boundary between the air and the water is there anyway. They note the position for every minute for 5 minutes. Student then covers the underside of one of the leaves in petroleum jelly. Remember, underside, why is they told us the underside? Probably because that's where most stomata are. In petroleum jelly, why that? Well, that kind of stops water being passed through before repeating the measurements. This was continued until the undersides of all the leaves have been covered. Okay, right, so done one leaf at a time, just again think what they mean, number of leaves, so literally doing one leaf, then the next, then the next, then the next. So gradually reducing how many stomata are available for use. Again, get your head around the data. So we're increasing the number of leaves covered. So we expect transpiration to go down. The position of the meniscus. Well, let's look at the last one first of all. Again, it's moving much less as it goes down. And I'm just going to skim as well to make sure that the rate looks reasonably even. So 20, 40, 60, 80, 100. It's fairly even. Pretty much that. So what I'm looking for is most of the time these are kind of going up together. Like it's an equal amount of movement per minute. I'm just making sure none of them obviously don't go up and then plateau. They don't. Right. That's how I kind of approach the table. I'm kind of breaking it down, and now it just makes me, I'm not kind of being led by the exam question, by misreading the exam question, because I've pre-analysed the graph myself. Assume sensitive result is the graph. Figure 25.8 shows graphs. Right, position of the meniscus. Let's correct examiner millimetres. Really having fun with my pen today, right? Anyway, it should say millimetres. The examiner doesn't like the fact I'm correcting the graph. And time, yes, there should be units down at the bottom. And what's happening. So, lovely key. So, a single dashed line is 0 leaves. The line with the dots is, or big lines, is 5 leaves covered. Right. Again, I would expect most leaves covered to have the lowest rate of transpiration, and the ones with the 0 leaves covered to have the highest rate of transpiration. Right, now it says, so you have over a page of reading to get to the question, and this is important that too many people leap to here and then go hunting and then make a mistake. State 2 different types of information the student has missed from the graph. Well, we've kind of seen it. So they have missed out the axis units. Okay, now I'm a bit of a quandary. So it says 2 marks, I've got to give 2. Didn't put it in bold, but the axis units, this is different types of information. So is this and this can be treated the same? So I'm going to look for another one because it does say different. I'm picking out all those key words of information that they have missed. It's got what it was covered. Got the key. I guess we can go with title. So I've got to make a choice. I've got to make a choice because they've told me how many answers I can give. So if I wrote, if I write this wrongly, my third answer could make my other answers incorrect. So I'm going to say they've missed out the X and Y axis units, and they've missed out the title. And I'll kind of, they missed the title. So I've kind of worded the X and Y axis just a little bit cleverly because I'm quite honest, I haven't seen the mark scheme. I'm not convinced that they just want these two as separate things, but I don't think that's different types. But I haven't written it in a way that kind of examiner would take, perhaps would ignore this answer. Hopefully they'll see that as one and take that as my second answer. Because if I did put 3 things, let's say I put axis units, missed title, and I'll make something up. Let's like a different dotted lines or something on the graph. The third answer, if wrong, will cancel the second answer, and you only get 1, even if you put 2 correct statements. So we can't list endlessly. So that's the hesitation. Use the graph to calculate the minimum rate of transpiration. Show your working. We show workings because if you make a mistake with the calculator, you can still pick up 1 mark. 2 marks. Little clue here. So if I'm really stuck on how to work at rate respiration, it's millimeters per minute. Okay, the -1 means per. So really, I'm doing millimeters divided by minutes. What's going on today? But that unit is your huge clue. So millimeters, which they missed out, per minute. But I do need to know the minimum rate of transpiration. As we've identified before, this one down the bottom is going to give me the lowest answer because I've already seen it's got the most leaves covered, so I'm looking for here. All right, how do I do it? Well, it's a nice flat line, so I can measure anywhere. It's a gradient, I hope you're familiar with that. I could go right to the end and I can carry it across. I can see, it's best to come on a pen and a screen, be easier on paper. It's 1 little square down. There's 5 little squares per 10, so that makes it 28, and that is in 5 minutes. Okay, the larger you go with your gradient, the more accurate you're going to be. You could also perhaps have gone down here where I've circled, and that almost crosses that 10 line there as well, but it's quite a fat line. So if I had 28 over 5, it gives me what, 5.3-ish, okay, around about that. The examiners will accept a range usually when there's a bit of a thicker pencil line again. So, right, suggests how water is being lost from the cut stem when all the leaves have been treated with petroleum jelly. So it says from the cut stem. So it's got 2 marks here. So I might want to make 2 points. It doesn't necessarily lead to point explain. Let's go back and look at the diagram. Remember what's about everything being important? I've got rubber tubing. Well, I could be losing some through leaks from the rubber tubing. It could be losing some through the, it does say leafy shoot. Remember what's about everything being important? Is there going to be some stomata on the leaf and the stem? Or again, we've highlighted the fact that the underside is a stomata on the top surface, and for many plants there is. So let's put those 2 right. I think my favourite answer is stomata on the top surface. Some lost through stomata on top of leaf. But I want to make 2 points because it's giving me 2 marks. Some, I'm going to go for the rubber tubing because it's different from the rubber tubing connection. I'm not going to say from the rubber tubing itself because the rubber doesn't lose any water. So I've got 2 points there, and that makes me a little bit more confident I'm putting the right answer. It didn't say, no, give me 1, give me 2, so it's okay, I'll put 2 points. Suggest 2 possible sources of error in this investigation. Well, error is something that will lead you to inaccurate results, not measuring a true value. So let's just go back and have a look at that data again, why we might have lost. So what we highlighted could be useful. Well, look at the data, they've only measured to whole numbers in millimetres. That's one thing. They haven't. There's no repeats, but do in my head, do repeats lead to errors, or do repeats just show the reliability of the results? So I'm not going to link them with repeats. I don't think repeats is the right answer this time, because that's to me about reliability. If I did it 3 times, would I get 23, 23, 23, or would I get something different? I don't. So I don't think that's going to help me with errors. We've already kind of mentioned it. I think that some water might be lost through the top of the leaf. So let's think about also in any experiment, would your control measure keep the same? Well, what they controlled, let's go and have a look. Actually, I've not highlighted anything that they've really controlled. So that means between one leaf and next, not controlled. Temperature, that's always one to watch out for. And we also know that wind speed and some kind of air movement. Right, however, I've now got 3 answers, so I'm going to have to do sort of a family fortunes top answer style thing. I'm a little bit concerned actually on hindsight that this answer is repeated, and you never get a repeated answer in an exam. So I'm going to take this one out. And I think the not controlling is my better answer. Let's just have a look. Mark's getting into that last question. So it's 6. So they've gone with so first 2 is right, it's going to evaporate from upper leaf surfaces, although we missed out the key word there. So the key word is evaporation. So always try and science it up. We've said water's lost through the upper surface. They did want it developed, they did want a point and explain. I did say I do these cold, so hopefully you see my mistakes and we'll improve next time together. And here, so they now are looking a little bit more about water escaping. That's where the rubber tubings come in. So the error of reading the position of meniscus, chutes not cut underwater, leaks in the apparatus. So we didn't get that one, but I would argue I think they've gone with error in terms of the apparatus system setup, but always evaluate the controls as well. It's a little lesson there to take away. Right, thank you for listening, guys. Again, hopefully we will improve our technique.